Hello, 7th graders. This is your last lesson of the year. Exciting, I know. It's lesson 9.4 on independent and dependent events. If you're following along in your book, we're on pages 406 to 408. It's a lengthy lesson. All right, let's get to it. So 2 events. We first need to understand what are independent and dependent events, and that's the first part of this. So independent events, they are independent if the occurrence of one does not affect the likelihood of the other. So if you spend all night studying for your science test, is that going to get you 100 on your math test? I really don't think that those 2 events are linked. All right. 2 events are dependent if the occurrence of one does affect the likelihood that the other event will occur. So if you study all evening for your math test, the likelihood of you doing well on your math test, that's linked directly to that. All right. The likelihood of you understanding what we're doing in class tomorrow depends on whether or not you actually watch this video. Those are dependent as well. All right. Example 1. Identifying independent and dependent events. So all we're going to do is look at these 3 examples here, and you're going to tell me, well, I'm going to tell you, and you're going to write it down, whether it's independent or dependent. So you flip heads on one coin, and you flip tails on another coin. Now, what you flip on that first coin, do you think that the other coin's like, oh no, they flipped heads, I better make it tails? Like, they don't know, they can't think about it. So what you do on one coin has no effect on the other. That makes these 2 independent. And we can tell because one does not affect the other. You should write that down. One does not affect the other. Okay. Next, example B. Your teacher chooses one student to lead the group, then chooses another student to lead another group. Now, looking at this, you might think, well, those are 2 separate things. They don't matter to one another. But if I pick the first student to lead that group and they're leading their group, are they able to lead the other group? No. So who I pick the first time can't be picked again. So these events are dependent on one another. So dependent. And we're going to say one does affect the other. Oops. I'm going to try to say that. So maybe over here you box the not and box the just does. All right, last one. It could go either way. What is the chances of it being dependent versus independent? Uh-oh.
What are the chances?
What are the chances of our phone ringing in the middle of the lesson? Right. All right. You choose a blue marble from a bag, and you set it aside. Then you choose a green marble from the bag. So what are we thinking here? You picked a blue one, you put it aside. So is it possible to pick that blue marble again? No. So you've just kind of changed things here. So yes, these again are dependent. The same reason you can't pick the blue marble the second time. So you cannot pick the blue marble again. All right. So independent versus dependent. Got it down, Pat? I hope so. We'll find out tomorrow. Next. All right. The probability of 2 independent events, A and B, is the probability of A times the probability of B. And this is the fun, mathy way of saying it. So if you have 2 independent events, meaning they don't affect one another at all, this is what you can use to figure out the likelihood of something happening. So the probability of these 2 events is equal to the probability of the first times the probability of the second. There's actually 2 ways to figure this out. There's one that's lengthy and time-consuming that I'll show you first, and there's one that's really short and sweet, and I'll show you that second. I like to save the best for last. All right, you flip 2 quarters. What is the probability that you will flip 2 heads? So method 1, I think you've probably all seen a tree diagram before. This is my guess. So you have this quarter, right? 25. When you flip this quarter, it can either be heads or it can be tails, right? So this is flip 1. Oops, flip. Flip 1. So the second time you flip, this quarter here, it could be heads again, couldn't it? Or it could be tails. Now, if you flip heads the first time and heads the second time, that would give me heads, heads. heads, tails would give me heads, then tails. I'm hoping that this is review and it's making sense. If it's not review, we'll talk about it more in class tomorrow, don't fret. Alright, this tails, again, the same thing could happen. If you could flip it, when you flip it again, it could be heads the second time, or it could be tails. I should probably write flip 2 over here. So if the first time it's tails and the second time it's heads, we have tails, heads, or we have tails, tails. So the probability of flipping 2 heads, you're going to find your answer down here. These are all the things that could happen. And as you see, heads then heads again happens 1 time out of the 4 possibilities. So the probability of 2 heads, it's a fancy way to write it, probability of 2 heads is equal to 1/4 or 25%, whatever you want to say. Alright, method number 2. We can just multiply the probability of both. So we want to take the probability of heads times the probability of heads, because both times, sorry, I think it goes a little bit. Alright, so probability of heads is equal to, think about this, when you flip the coin, it's either going to be heads or tails, right? So that means you have a 1 out of 2 chance. The probability of heads again is still 1 out of 2. So when I say probability of A and B, the A is the probability of heads and so is the B, because you want to get heads, then heads. Okay, so the probability of 2 heads is equal to the probability of A times the probability of B, which means 1/2 times 1/2, which is, yes, 1/4. So the choice is yours. You can make a tree diagram. You can look at all the outcomes that are going to take place. It's lovely for visual learners. Or we can just say, okay, the probability of the first event is this, the probability of the second event is this, multiply them together. All right, turn your paper over. We're not done yet, because we have to talk about the probability of 2 dependent events. So now the events depend on one another. When you flip a quarter, it doesn't. But this flower example, one event does depend on the next. So if we have 2 dependent events, then the probability of A and B, it's equal to the probability of the first event times the probability of B after A happens. Probably sounds a little bit confusing, but I think after we go through it, it'll make sense. So with this lovely vase, it contains 7 purple flowers, 9 yellow flowers, and 12 pink flowers. You randomly choose a flower from the vase to take home and give to your math teacher. Your friend randomly chooses another flower from the vase to take home. What is the probability that you choose a purple flower and your friend chooses a yellow flower? First off, the reason these are dependent is because when you take that flower out of the vase, you don't put it back before your friend takes their flower. So the flower you took, they have no chance of getting that flower. That makes those events dependent. All right, so the probability that you'll choose a purple flower and your friend chooses a yellow flower. The first thing we need to know is your event. Event A is the probability of you picking the purple flower. So in order to figure this out, we need to know how many purple flowers there are in there out of how many total. If you look back up, it says that there are 7 purple flowers, and we have 7, 9, and 12. So when you take 7 plus 9 plus 12, you get 28. I'm hoping when you look at 7 28ths, you think, oh, those are both divisible by 7. Let's divide them each by that. And 7 divided by 7 is 1, and 28 divided by 7 is 4. If you didn't see that, the answer to do I have to simplify is yes, always. Every time. Please, for the love of math, simplify your fraction. 1/4 is way easier to multiply than 7 28ths. It just makes sense. So here's the probability of event A. Now the probability of event B is your friend choosing the yellow. Now this is the event of my friend choosing the yellow after I chose a purple already. So there are still 9 yellow flowers in this vase, but didn't I just take one out? So that means there are no longer 28 flowers in the vase. That's a fancy way to say vase, just like Target is Target. So 28 minus 1, there are now 27 flowers in this flower pot. Again, 9 27s, ooh, those are both divisible by 9. 9 goes into 9 once, 9 goes into 27 3 times, or 9 divided by 27, math, enter, enter. 1/3, ba-bam. So here's the probability of A, here's the probability of B, after probability of A. And it says up here that all you need to do to find the probability of the event is multiply the first by the second. So all we have to do to find the probability of purple, then yellow, is take 1/4 times 1/3. It is not 2/7 because it's multiplication. 1 times 1 is 1. 4 times 3 is 12. So there's a 1 in 12 chance that you will pick a purple and then your friend will pick a yellow. And if you bring Mrs. Sullivan and I a yellow or purple flower tomorrow, we'll have a Starbucks and maybe a Jolly Rancher for you. Enjoy. Bye-bye.